In this experiment, we're going to be assessing another factor that influences the rate of diffusion, and that factor is the size of the molecules. So what I have here is I have Petri dishes. So a Petri dish, if you're not used to it, it has a lid and a bottom. We often use this in microbiology, and they are filled with agar for growing. Microbiology, sorry, a little bit of a stumble there. So when you look at these, they actually have two depths. The bottom is a deeper, and then there's a lid that's not, it's more shallow. So please be careful when you use these that you are basically using the bottom deeper for the container. All right, so what I've done is I've marked more or less the middle. There's a little black dot here because that's where I want to put the molecules. And I've got a ruler under here because, again, rate of diffusion is how far you travel over time. And so here, I'm not going to bother timing it because they're going to be put in at the same time, basically. And, but ideally, we'd have a timer, and you can use your phone to do this, or a stopwatch if you have a stopwatch or watch. It doesn't really matter, right? All you're trying to do is make sure that the time is constant for both. So just like with the temperature one, I'm not going to watch the time because you're really looking for the effect. And you're going to see that because I'm using two different dyes here, and they have a different size. So one of the dyes is potassium permanganate, and the same concentration, 0.1 molar, and this one is 0.1 molar. But methylene blue is a considerably larger molecule than potassium permanganate. So we're going to put 1 drop of each into the 2 test tubes. Now, honestly, this is a very small container, so if I had these filled with water, like I've done in the last couple experiments, it would spread out so fast it might be difficult for us to tell. So in this particular case, we're going to use corn syrup, because corn syrup is highly viscous and it'll slow down the molecules. So again, gets to be a little bit of a mess, so be very careful as you set these up, right? So we're going to kind of let that drip out there, right? And kind of let it fill that dish. And again, clear, obviously, so we can see the molecules. We couldn't use the dark corn syrup like we used for our cell experiment. And we're going to kind of cap that off and put that over the side and get another bottle here to more or less make these the same, again, volume-wise. But here we're just using this as a medium that the molecules will move in. And we wanted to slow the molecules down a little bit. Okay, so again, I've got them sitting. I've got a metric ruler here, which is 15 centimeters, and I'm going to look for them to spread out from that point. Now, they'll spread out in all directions, but we're going to just assess one of the vectors here in each case. So let me put the potassium permanganate, a drop of that in. Right, and it's really hard to get this right because, here we go. And again, on the surface there. And then we're going to put the methylene blue. So watch what happens there and there. All right, so there was a little bit of time in between that. But if we correct for that, we see that the potassium permanganate is actually spreading out considerably faster. And again, we could actually record the distance it travels, and we could record the time that has passed. But potassium permanganate is a considerably smaller molecule compared to methylene blue. So eventually they'll both fill the dishes, and then it won't be exciting anymore, right? Hoping you are a little excited right now. But in the meantime, you can see that, again, smaller molecules do actually move faster than larger molecules. So we'll let that go, and we'll check on our other experiments here in a moment.